Yes. So combination of resistor, we have started what is resistor, what is resistance. Rho is equal to one formula I teach. What is that? Remember?
Yes, sir.
R is equal to, what is the formula? Tell me.
Sir, I wrote that tau and only, sir.
R is equal to,
No, sir. The one having tau like wavelength to mass by V into D.
I'm asking what is R? You right or not?
I don't know, but sir.
Here is a mind. Let me show you again. I'm asking what is the value of R? What is rho? Resistivity formula. Why didn't you write like? If I will not ask, then it will be like that. When that PDF is missing here. It. Please take all the notes. Still, did you write or not?
Yes, sir.
What is the value of R? Tell me. What is the value of drift velocity formula?
VD equals minus E, a capital E, tau by M.
PD is equal to E tau by M. Okay.
E, tau by M.
What is the formula of resistance? Tell me.
Lambda into M by V into T.
Lambda, I didn't use lambda. Where are you? Lambda I don't use. R is equal to this equation. I think you forget. R is equal
So,
to.
yes.
Please don't forget. R is equal to. I'm writing again. R is equal to right now. N is square. N. R is equal to N is square tau A by N is square tau A by ml. This is the value of resistance. Clear? And if
Yes, sir.
you look at it carefully, this N is square tau. This is N is square tau by, what is this?
M. Drift velocity.
Wait. Here I'm also confused because of I is equal to what? Wait. Again I will derive. Again I will make you remember. I is equal to anyway. I is equal to N E A V D. Clear? Then what is the VD? VD is
Drift velocity.
E tau by M.
M.
Clear? This is what you have learned. I am simply asking magnitude. What is E? Potential difference by L. Then I will be what? N E square then tau by ml, and here a n is square a tau by ml. Or here what is there? Tell me what is left. Anything left here? Yes, into b.
Sir, V
Clear?
and D is also not there, sir.
I is equal to n e square tau a v by ml. Clear?
Yes, sir.
ml is square ml by n is square tau into a equal v by I. What is there? V by I. Clear? Notice V by I what? Tell me. What is this V
Sir,
by
I
I?
have a doubt.
Yes.
Why is D not included along with V?
What?
Why is D not included along with V?
What D?
No, sir, for drift velocity.
Drift velocity I take na y I is equal to n e a v d. Look at here. Look at here. I is equal to n e a v d. E tau by m. What is E? E is the potential difference by the length of conductor. Like this. This is L A. Then how much E? Tell me. E will be
E tau by M V.
V by L. What is V? V is the potential difference across this conductor. This is what I have explained. Again, go back to the lecture. Watch the lecture carefully.
Yes, sir.
Here. So,
Yes, sir.
R is equal to V by I. What is Ohm's law? Ohm's law is V is equal to IR. Then R is equal to V by I. So, this ratio, R is equal to V by I. This is basically what? You can see ml by n square tau A. ml square by n square tau A. M constant, L constant, length of conductor, M is the mass, N is the number of, what is N? This is small n. Small n means number of free electrons, free electrons, number of free electrons per unit volume. Clear? What is N? N is the number of free electrons per unit volume. Clear? Wait, let me check other sources because here too much problem. I will look at the Zoom whiteboard. Wait. My whiteboard is visible to you? Tell me, is it
Not
visible?
yet, sir. Yes, sir. Now it's visible. Yes, sir.
Visible. Okay. Is it visible now?
Yes, sir. It will be.
Okay, okay, then it is so. So what I have explained, I is equal to NEA VD. Clear? For example, if you have taken a conductor having length L, having length L, and the cross section area is A, then VD, V is the potential difference across this conductor. The electric field formula yesterday I have explained E is equal to V by L. Potential drop per unit length. V is the potential drop across the conductor. Then V will be what? I is equal to N E A. VD is E tau by M. What is this N? N is the number of free electrons per unit volume. N will be N E square A tau by M. What is E? E is V by L. Clear? Is it clear to you?
Yes, sir.
Now, how will I go back down? Phase 1. Clear?
Yes, sir.
Now look at again what you get. I is equal to I is equal to wait. I is equal to N E A V D. V D is E tau by M. I is equal to N E A V D. V D is E tau by M. So can I write like this? N E square A tau by M. What is E? E is V by L. Clear? So if I ask like N E square tau A by ml. What is this? V. If I take this left side, ml by n E square A tau. It will be V by I. Now what is this? V by I. V by I is basically, it is the ratio of ml by n square tau A. Clear? Any doubt?
No, sir.
Now m is constant. M is the mass of electron, charged particle. E is the charge of electron. A is the cross-section area. Tau is the relaxation time. N is the, what is the small n? Number of free electrons. Number of free electrons per unit volume. Per unit volume. Clear? Now,
Yes, sir.
if I keep at constant temperature, see m can't change. We can't change m. M is constant. Length never change. Area is never change. E never change. For a for a for a given material, for example, aluminium, the value of n is constant, number of free electrons per unit volume, m is constant, its length is constant, area cross section is constant. Clear? At constant temperature, what is constant? Tau is also constant. Then this entire term ml by n square A tau is constant. Clear?
Yes, sir.
Any doubt?
No, sir.
Now, if it is constant, can I write that this constant is K? ml by n square a tau is constant. Its value is K. It is equal to V by I. And if this is constant, can I write like this? Wait. If this is constant, K is constant, then can I write like the V proportional to I?
Yes, sir.
This is Ohm's law. Ohm's law. Ohm's law. V proportional to I. What is V?
Potential
Potential.
difference.
What is I?
Um,
What is I?
Charge.
I. This I is charge.
Current.
Current. Yeah. Then what is this small e? Hello. Hello. Hello.
Sir, is my voice audible, sir? I think my mic was mute.
Yeah. Please tell me what is small e? This is small e. Tell me. Hello. Please open your
Sir,
camera
is my voice?
first.
No, sir. Actually, I was speaking for a while. I realized that my mic was in mute.
Okay. I'm saying what is small e?
Is it the value of the electron's charge, sir?
Okay. What is small L?
L is the length of the conductor.
Okay. It means you are understanding. So this is K. This V proportional to I. This is Ohm's law. Clear? Now remember, this is ml by n square a tau. I just take at constant temperature this entire term. I take as K. And this is constant. And this is what you have learned, V proportional to I. Ohm's law. Definition is at constant temperature and pressure, potential drop is directly proportional to the current. V proportional to I. This is what you have learned. And this is a derivation of this. Now next thing, if I ask V proportional to I, Ohm's law. If I draw a graph V versus I at constant temperature, it will be straight line for Ohm's law. What is the relation? Tell me what is the value of K? Tell me.
Ml by n square tau a.
N square tau A.
A.
Clear, check again. N square, this is now. So when I remove this, V, what is the slope? If I ask what is the slope of this graph, this theta,
Constant.
constant. And if I complete this a triangle, this will become V and this is become some value of current. So ratio this triangle, this slope of V versus I graph tell us resistance. Slope of V versus I graph indicating what? Resistance. Now this is what you have learned. Yesterday I have explained this. Now if I remove this V is equal to proportionality sign, some constant will come. That constant is K. And what is the value of this K? K is ml by n square tau into
Tau
tau
A.
into A. So this is the resistance, this whole term. This is R. So what is resistance? Resistance formula is M L N square tau. ML by N square tau. L by A. This is the resistance formula. And you have learned this. Let me clear this. R is equal to what is this?
Which one, sir?
This is what you have learned. R is equal to, this is entire term, rho M by N square tau. This is rho L by A. So what is rho? Rho is M by N
N
square
square tau.
tau. This rho is electrical resistivity, or we can say resistivity. Resistivity. And you can see resistivity formula, it is a property of material. M depends on material. N depends on material. N depends on material. And tau depends on temperature. Clear?
Yes.
So tau depends on temperature and our N depends on material. Next. So what is the value of R? Tell me. R is,
R rho L by A.
what is rho?
Rho is M by N square tau.
Clear? This is for metals. Metals. Okay. Resistance is formula valid everywhere, but for metals. Metals you have learned on increasing temperature, resistance also increases. This is what you have learned. Why? Because on increasing temperature, tau, on increasing temperature, tau, increase or decrease?
Increase.
Very good. Tau decrease, then rho increase, then R increase. Clear?
Yes, sir.
This question we ask in the competitive exam. So write down next combination of resistors. Next topic, combination of resistors. Clear? So what is combination of resistors? From the name itself, we are going to combine 2 resistor, 3 resistor, 4 resistor, 5 resistor. So there are basically two. Why we are actually combining? Because we want the high resistance. Clear? Sometimes we want low resistance. There are basically two combination of resistance. One is series, next is parallel. Clear? Now what is series? First we will learn what is series combination. Series combination, look at here. First combination is series. Write down the heading, series combination. Clear? So what is series combination? For example, you know what is the symbol of resistors? This is symbol of resistor. How many resistors are here? T. R1, R2. What is R1, R2? Resistance. R3. So series means resistance are connected end to end. End to end means series means end to end connection of resistors. End to end. End to end. Clear?
Sir, I'm not clear with this, sir.
I will explain then only will clear na. And until now I didn't start na this topic. Series
Yes, sir.
combination means end-to-end connection means, for example, this register, this register, this register. I simply connect like this. Can you see this? Just give me the number one, number one, number two, number one, number two, 1, 2, 1, 2, like this. So can you see one thing like 2 is connected with 1, 2 is connected with 1, 2 is connected with here no register. So end-to-end connection means end of this register is connected with the end of this register. End of this registers are connected with the end of this registers. Clear? End-to-end connection. End of registers are connected. Just give the number 1, 2, 1, 2, 1, 2. So 2 is connected with 1, 2 is connected with 1, 2 is connected with 1 like this. You will not find 1 is connected with 1 or 2 is connected with 2 in series combination. Is it clear? You never find 1 is connected with 1, 2 is connected with 2 in series combination. So series combination means end-to-end connection. Clear? Now,
Yes,
for
sir.
example, I am using a battery. Battery of terminal voltage. You know terminal voltage? Clear? Terminal
Yes, sir.
voltage or forget.
No, sir, I remember.
Battery, for example, I just take one cell. It is having the voltage V. Positive, negative. Like this. Wait. I can go down also, na? I forget this. So, for example, if the battery is having voltage V and I just connect all the resistors with this cell like this. Then what will happen?
Sir, I left the meeting due to internet issues.
You left the meeting or I thought like meeting is ended. His screen is visible.
Yes, sir.
So can you see like this V voltage is applied across
Yes, sir.
R1, R2, R3. For example, V is 100 volt. So this 100 volt is going to consume where? For example, this load, R1 load is bulb. I'm just drawing here. R1 is bulb. R2 is fan. And R3 is, let us suppose, one more tube light like this. Any tube light. Clear? R1, R2, R3 are loads, or you can say resistors. Clear? Now you just tell me, when you connect these three loads in series combination and connected with a 100-volt battery or cell, then what will happen? They start, bulb will glow, fan will rotate, and this tube light glow. You just tell me, is it free of cost? No. Is nothing is free of cost in this universe. Then battery energy is going to consume where? Across R1, R2, R3. Or we can say battery voltage. Some voltage drop across V1, some voltage drop across R2, that is V2, some voltage drop across R3.
Sir, screen is not visible, sir.
It's not visible. So you just tell me now. Hello?
No, sir, now only it's not visible. First it was visible, now it's stopped.
Okay.
Yes, sir, now it's visible.
Visible now?
Yes, sir.
Take the notes because it is not saved.
Yes, sir.
Here, please don't. Yesterday, I think you have taken or not. I don't know. Please take the
I
notes.
took there was like internet issue, so I think I might have missed something in the middle.
Yeah,
We'll check
don't
the
miss
videos.
because I don't know it will be recorded or not today because lectures may be not recorded nowadays because some problems are happening. Internet issue here also. So what I'm explaining, for example, there are three loads. Load 1, load 2, like this. R1, R2, R3. And I just connect with a battery or cell. Positive, negative. V volt. Clear? Then
Yes, sir.
free of cost. Free of cost, they will not work. They will consume energy from the cell, or they will say take some voltage from the cell. So let us suppose V1 voltage taken by the bulb, V2 voltage taken by the fan, V3 voltage taken by the next tube light. Then this entire voltage is going to consume where? This entire voltage, if I ask you, this entire voltage of the cell is going to consume across V1, V2, and V3. Is this clear?
Yes, sir.
Again, I will draw here. If this is R1, R2, consume means what? Voltage drop. Some consume means drop. V1 here, V2 here, V3 here. And current I is going like this, V here. So can I write this V1 is equal to, as per Ohm's law, I into R1? Like this. I into R2, I into R3. So V will be what? I R1 plus
R2
R2
plus R.
plus R3. So what is this? Actually, R1 plus R2 plus R3 what? It is the equivalent resistance. R equivalent. Equivalent resistance of all the resistance means what? R1, R2, R3. R1, R2, and this is R2. If I combine all the resistance, if I combine, this is cell, battery, whatever else. If I combine these, all the resistance combined, Then I got the equivalent resistance. That is R equivalent. And across this, how much voltage drop? P. Meaning of this. Across this R equivalent, how much voltage drop? P.
Voltage is concerned.
Understood?
Sir, I have uh, sir, connecting in the sense when R1, R2, and R3 are joined together.
What?
Connecting in the sense R1, R2, and R3 are joined together.
Yes, yes, yes. When combine means we just find the equivalent load. For example, you just switch on bulb, then tube light, fan. Then in place of all these three, you just switch on geyser, which is having the same resistance as the sum of these three. Clear? Now geyser will operate with the same voltage V. It will take 100 volt. Why? Because it has resistance which is equal to the sum of all the resistance. So R1, R2, R3 are connected end-to-end connection. So we say it is a series combination. End-to-end means if this is 1, this is 2, this is 1, this is 2, this is 1, this is 2. 2 is connected with 1, 2 is connected with 1 like this. Is it clear? And combine means you just combine these three. In place of these three resistance, you just place one resistance that is R equivalent. And when you multiply R equivalent with I, you will get the total voltage supplied by the cell or battery. Then how much voltage drop across R equivalent is same as the battery voltage. Clear? Series combination.
Yes.
Now, one disadvantage of this resistor is what? If by mistake I have used what? For example, here tube light, fan, and this another tube light, all are connected in series. If by mistake fan damage, if by mistake R2 damage, then will R1 R2 work? If by
No,
mistake
sir.
this R2 damage, then will these two work?
They
No,
won't.
because circuit break. Circuit break. That is why there's a big disadvantage. If any of the appliances stop working, then all other appliances are not working properly. This is the disadvantage of series combination. Clear? Orally I told because in competition they can ask what is the disadvantage of series combination. Next you have seen, for example, if I ask like this, R1, R2, R3. Then in series across R3, current is I, here current is I, here current is I. Because all are in series. In series
Series.
combination, current is same. What is same? Current. Current is same. Current is same. But V, voltage is not same. Voltage is not same. Across R1 voltage is V1. Here V1 voltage, here V2 voltage, here V2. V is not same. Clear?
Yes,
Current
sir.
is same in all the resistors. And what is the equivalent of these three? R equivalent formula? R1 plus R2 plus R3. This is the way to solve. Clear? Any doubt?
Yes, sir.
After this, write down parallel combination. Write down parallel combination. Parallel, write down the heading. Parallel combination. Parallel combination means same question, same thing. Like bulb, fan, and one more. Two take. We will take two. Okay. These two, for example, this bulb is having the resistance R1. Fan is having the resistance R2. So I'm denoting this resistance by like this. Now, what is happening in parallel combination? Give the numbers. This is 1 and 1. Again, I'm giving. This is 1. This is 2. 1, 2. Clear? Now, in case of, and this is our cell, positive, negative, voltage. What is happening in case of our parallel combination? All the, for example, 1 and 1 and number 1, both are connected with the same point. 2 is connected with the 2 connected with same point. 2 is connected with 2. And here our cell. Understood?
Yes, sir.
This is AB. Now, by doing this, what is happening? See, potential difference already have explained. It is the difference of potential between 2 points. This V, if you look at this V, it is a potential difference across A and across B. This V is what? It is a potential difference across 2 points, that is A and B. Clear? Potential
Yes, sir.
difference across 2 points. It needs 2 points. Now you can see V is the potential difference across A and B because there is no such points. Only this A is here, then branches. One branch here, next branch here. Similarly, B. So this V is the potential difference across A and B. A comma B. I can say this V is actually, it is the potential difference across AB. Now you can see the end of this resistor is also at A. Similarly for this resistor, second end, it is connected with A and B.
Yes, sir.
This resistor end is connected with A. Similarly for end B, sorry, end 2 is connected with B. Similarly for this our fan, its end is also connected with A, B, B. So you can see potential here also B, here also B. Because points are same, points. Here AB here, AB here. So potential difference always B, it is the potential difference means it is the difference of potential between 2 points. If those 2 points are same, then potential is same across all the appliance. So here also V, here also V. Then current. Battery is giving current. Battery is giving current like this. Here battery is giving current I. If battery is giving current I, then how much current it will take? I only. If current I is going here, then how many wires are here? After reaching, this is the junction. 1, 2, 3. 1, 2, 3. 3 wires are meeting. Junction means it is a point where 3 or more wires are actually meeting. That is junction. Junction A. At junction, current divide. For example, current I is coming. through this I1, here I2. For example, value of I is 6 ampere. Then 3 will go here, 3 will go here. For example, it is 8 ampere. Then if it is 2 ampere here, here 6 ampere. So this is junction. This is junction. Junction means it is a point where 3 or more than 3 wire actually meet. You can see wire 1, wire 2, wire 3. Now this I1 current flows. Finally, I1 is coming here, I2 is coming here, I2, I1. Then these two current, this is a junction. B is a junction, at junction, these current are going to merge. And finally, you are getting I current. Why I current here? Because battery is giving I current. It will take I only. If a cell is given 6 ampere current to the external circuit, it will take 6 ampere. This is basic rule. Now, as per Ohm's law, you just tell me, as per Ohm's law, in R1, what is the value of I1? R is equal to V by I will be V by R1. Question 1. Similarly, I2 will be what? V by R2. Then if you look at here, the current I is going to distribute among I1 and I2. Can I write like this? I is equal to I1 plus I2.
Yes, sir.
Can I write or not?
Yes, sir.
So if I ask like I is equal to I1 plus I2, what is the meaning of this? I,
Current split.
for example, I1 is how much? V by R1. I2 is V by R2. I is equal to V by V common 1 upon R1 plus 1 upon R2. Clear?
Yes, sir.
What is this? This is 1 upon RP. I is equal to V by RP will be what? V by I. What is the value of RP? 1 upon RP. 1 upon RP is 1 upon R1 plus 1 upon R2. Then RP will be R1 R2 by R1 plus R2. What is RP? RP like same. RP is the equivalent resistance in parallel. What is R? Clear or not?
Yes, sir. Clear.
Equivalent resistance in parallel. So what is equivalent resistance? It is basically the battery. How much voltage supplied by the cell divided by total current I. It is what? Actually, look at here. R1, R2, battery. I is current. It is given the I current, and its voltage is V. Here V, here V, here V. I is coming. I1, I2. If battery is giving I current, will take I current. So what I am explaining actually RP. RP is the equivalent resistance. It is basically what? This V by I. V is what? Voltage supplied by the battery and its current. How much current it is going to supply? That is RP. So I can I write like this? RP is what? V by I. Or can I write V is equal to what? I into RP. So what is the meaning of this? Can you draw this? V is equal to IRP. V is equal to IRP. How will you draw? You will take one resistor RP like this. Across this, how much current is coming? I. Then how much voltage? V. I can draw like this. Is it correct?
Yes, sir.
So this RP is the equivalent resistance. And here you will see this is junction. How many junctions are here? Two. Is it clear? So in case of parallel combination, what is a constant? Voltage. Why voltage constant? Because all the resistance are connected across the two same points, or we can say points are same. In your home, if by mistake one fan is not working, then other fans are working. If your geyser stop working, then fridge is working. It is parallel combination is a big advantage of this combination. Any of the appliances stop working, then other appliances are working. That is a big advantage of parallel combination. In your home, how much voltage is coming? 220. How much voltage? 220 volt. This is coming from the powerhouse. Powerhouse, it is very high. Step down transformer is there, but 220 volt is going to supply it to all the appliances. It is not for a geyser only. This 220 volt is going to supply geyser, fridge, table fan, and your ceiling fan also. Clear? So 220 volt, it means parallel. Potential is constant. All combination are in parallel because voltage, same voltage is going to supply everywhere. So in case of parallel combination, what is constant? Voltage. Voltage is same across R1, R2, and R3. Clear? And what is different? I is different. I is different. I is different across R1, R2, and R3. Is it clear?
Yes, sir.
Any doubt?
Sir, I'm confused about what is the difference between. Yes, sir. Now I got it. No, sir. I am again having this doubt. What is the difference of I in parallel resistance and series combination, sir?
In series, current is constant. In parallel, current is different. You can see across this is R1, this is R2. Across R1, I1 current is going. Across R2, I2 current is going. This is the current supplied by the battery. For example, this is 10 ampere. Then if it is 4 ampere here, how much here? 6 ampere. So different current is passing through a load in case of parallel. But in case of series, you can see series means what? In case of series, is R1, R2, R3 are in series combination, then current will be same. Same current is going here. I is there is no junction here. Same current I. Here,
Yes, sir.
any doubt?
No, sir.
Tell me any doubt. Still, I'm asking.
No,
Now
sir. I don't
listen
have
me.
any doubt.
Series parallel combination is clear to you or not?
Yes, sir. Yes.
Please, I will request you to work hard more. You are on a
Yes, sir.
right track, but you need revision only. Today I
Yes, sir.
started with the previous things. Clear, it's no worry. You just revise also. It's a revision time. No worry. But I wish like you should. I know your exam is going on, and I know that is first priority. And even I know like Saturday you have exam now.
Yes, sir. Saturday
So
and Monday one.
Monday, which exam?
Saturday it's actually bit, sir. Monday, I don't know what exam this is. They did not give any clear information, but they are telling it like CO exam. They are going to select like top 40 students of 10th standard and make a separate class.
Okay, that is a different thing. You just I will suggest you. On Saturday you have test now, so that's why ma'am has asked me to conduct one class. At 8 o'clock you have a class.
Yes, sir.
That's why I told to join at 6:50, but due to some technical glitch, this thing happened. But no worry, this series parallel is done. Only numericals part is left. Tomorrow, not tomorrow. I think tomorrow you take rest. Day after tomorrow, once you Sunday I think science is reserved. Monday I will take your not Monday Saturday. I think Saturday we can take class.
Yes, sir.
Saturday you have after exam you will be free now. So Saturday I will start your numericals related to this chapter. Series parallel numerical you will solve. Many numericals, not a single numerical. Around 10-15 question will solve. Then only you will get a good this grip on this concept. Clear?
Yes, sir.
Okay, no worry. Any doubt? Tell me today's lecture.
No doubt, sir.
Okay, okay. So shall I stop?
Yes, sir.
Notes, please take because today I'm not so happy. I'm not like what I say. I can't say that I am able to extract. Let me check. Can I extract PDF? What to do?
Sir, I took all the notes for today, sir.
Okay, okay. Then it's good. Thank you. They are not allowing actually. Okay, thank you. Bye bye.
Thank you, sir.